Okay, welcome back. This is Mr. Bloom, and this is lesson 3.8. Let's get it something to talk about this with. This is lesson 3.8, slopes of parallel and perpendicular lines, and this is the perpendicular line segment. Objectives to relate slope to parallel and perpendicular lines. You've already wrote down the objective from the previous, so let's get on with the show. So when I'm looking this over, you got to keep in mind, we are checking out the formal definition of perpendicular lines does not tell us that they are opposites and reciprocals. Instead, it focuses on the product of the slopes of the perpendicular lines because the product of slope 1, the product of slope 1 times the product of slope 2 is -1. Perhaps that would be a better M if I took more time. So slope 1 times slope 2 is equal to -1. So we're going to make a conjecture about that. Okay, make a conjecture about that product. Well, those slopes of perpendicular lines are opposite reciprocals of each other. So what's that mean? If I had one slope be 2, the other slope has to be -1/2. Multiply them together and I get a -1. So you gotta make sure you're comfortable with your fractions. So moving on, key concepts, slopes of perpendicular lines. So remember, as I'm doing slopes of perpendicular lines, if two non-vertical lines are perpendicular, then the product of their slope is -1. And if the slopes of two lines have a product of -1, then the lines are perpendicular. Please notice that these are converses of each other. And then any horizontal line and vertical line are perpendicular. Now remember, any horizontal and vertical, a horizontal line has an equation, by the way, of y equals b. Okay, a vertical line has an equation of x equal a. Okay, and the vertical line has an undefined slope. And the horizontal line has a 0 slope. Okay, when I look at these, that's why they've got to tell us that the horizontal and the vertical lines are perpendicular, because undefined times 0 is not -1. So as we move on, checking for perpendicular lines. Hey, I just want you to find the slope. Okay, and again, let's look at this way. Because I'm given a grid, I'm going to be really honest. Slope 1 is rise over run. So a little different from what I did before. And now I've got a slope 1. This is line 1. And I'm going to go from here to here. I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So I'm going down 6 over 4. So my rise was -6. My run was 4. But I get to reduce this, becomes -3/2. So my slope is -3/2. And now I'm going to do the slope of line 2. My line 2 slope, my slope of line 2, rise of 1, 2, 3, 4, 5, 6. So I got a rise of 6, and 1, 2, 3, 4, 5, 6, 7, 8, 9. A run of 9. So rise of 6, remember rise over run. I had a rise of 6, run of 9, and get to reduce, and that is +2/3. Now, I'm going to check to see if these are perpendicular. It looks like they are because they look like they're opposite reciprocals, and I should probably write them in the same color I wrote them originally. So if I take the first slope, -3/2, and multiply it by my second slope, +2/3, I am going to get -6/6. Now I've got some people going, see Bloom, it's not -1, but hold your horses, because 6 divided by 6 is 1, and that is -1. So I know the two lines are perpendicular. So since the product, let's say this easier for us. Since slope 1 times slope 2 is equal to -1, the lines, got carried away. Let's say it this way. L1 is perpendicular to L2. And that is my final, and I have all that information to support my final position. Okay, so that's what we've got. Let's slide on here. Now, my 3 and got it. I want you to find the slope of L3 and you to find the slope of L4. But remember, I don't have a picture, so we won't be able to count. So I've got the slope equation up here just for your benefit, so you can use it. So turn it off, use the slope equation, and find slopes of L3 and L4. Welcome back. L3 slope, slope of 3, is equal to y2 over y1. Well, I got 7 over 2 and negative 1 over 3. My y is on top, the x is on the bottom from each point. And now I'm just going to find their difference. It's 8 and negative 1, so I got negative 8. Now, my slope of line 4 slope, okay, 4 is 6 over negative 2 and 7 over 8. Find their difference. And I have negative 1 over negative 10. Now I'm going to double check that to make sure I wrote things down. 6 over negative 2 and 7 over 8. 6 minus 7 is negative 1. Negative 2 minus 8 is negative 10. The slopes will not multiply because negative 8 times negative 1/10 is equal to positive 8/10. Okay, and that is not negative 1. So slope 1 times slope 2 is not negative 1. So the lines are not perpendicular. Now, let's see how we're going to use this writing equations. Writing equations of perpendicular lines. What is an equation of line perpendicular to y equal 5x? And I just have to write an equation. Okay, now here's the thing, this is the trick. I have to find the opposite reciprocal of that slope. So I got to flip it and take its opposite. So I'm going to use the slope perpendicular to that is going to be negative 5. And just on the side, negative 5 times 1/5, remember that's the same as 1, is going to be negative 5 over 5, which is negative 1. So it checks out, so it'll work. Now, I also have this point. So I'm going to use point slope. I got a point and I got a slope, remember, point slope form. So y minus negative 4, which is plus 4, equals negative 5 x minus 15. Now remember, since they only asked me to find an equation, I am done. Okay, this is in point slope form. Okay, good enough to be done right there. And again, if I wanted it in slope-intercept form, I just have to distribute and then solve for y. And I'm going to show you how that's done. Y plus 4 is equal to negative 5x. Now that's 5 times 15, but it's a negative times a negative plus 75. So y is equal to negative 5x plus 71 as my slope-intercept form equation. And again, I want to emphasize, this is the answer I'd totally have if all I had to do is write an equation. Okay, totally would start with point slope form, and then if I was asked, I could go to slope intercept form just like I showed you. But here, in this next one, see if you got it. What is an equation of the line perpendicular y equal negative 3x minus 5 that contains negative 3, 7? You're on. Turn me off and check it out. Okay, welcome back. First thing I got to do, it's a line perpendicular. I find slope and I flip it and take its opposite. So the reciprocal of that is 1/3. How do I know for sure? 1/3 times negative 3, because that's negative 3 over 1. That's times, is equal to negative 3 over 3, which again is negative 1. So that checks out, so that's totally rock solid. I forget the equation. Now I've got a point, negative 3, 7, so I put that in my point slope form. And I got y minus 7 equals 1/3 x plus 3. Now, that is my point slope solution. That is in point slope form. If I wanted to, I could totally solve in y minus 7 equals 1/3 x plus 1, because that's 1/3 times 3. And now I could just add 7 and go y equals 1/3 x plus 8. And that is my slope-intercept form. We'll bring that down. Okay, so that's a line perpendicular to the given line through the given point. Now, problem 5, writing equations of lines. The baseball field below is on a coordinate grid with home plate at the origin. A batter hits a ground ball along the line shown. The player at 110.70 runs along a path perpendicular to the path of the ball. So I'm at 110.70. If I'm going up 1 over 3, and up 1 over 3, and up 1 over 3, okay, that's the slope of this line. The slope that this player right here would have to run at the ball because they're at 110.70, that's 110.70 right there. Maybe I should use red because that's the color they got there. If I got 110.70 there, and I'm going to go down, I'm going to go the reciprocal of that, so I'm going to be on a slope that is the reciprocal of 1/3, which is 3, but negative. So I'm going to go down 3 over 1 on my 110.70 slope. So 1, 2, 3 over 1. 1, 2, 3 over 1. So my player is going to run this way. So if they're saying they want us to come up with the equation of this red line, okay, because if this one continues on this way, they should come in contact with each other right there, and that should be a 90-degree angle. So what is the equation of that? Well, I know I've got a point on that line, 110.70. I have a slope, so, oh gosh, I get to use point slope form. Y minus y1 equals m, x minus x1. So I know my slope, and I know my 70. Y minus 70 is equal to negative 3, x minus 110. Done. That's the equation. That's all I need. They don't tell me what, they just say equation of the line. So this is in point slope form. Okay? Now, what's the next thing? Suppose a second player standing at 90-40. Suppose a second player standing at 90-40. Let's find another color for a second player that's, ooh, I don't know. I use blue, green. Let's see if green's. So we're at 70, 90, 70, 90, 40. 1, 2, 3, 4. So at 90-40, we got a guy in green. Okay, so let's not be a guy in green. Let's be a different color. Let's be purple. Okay, so we got that purple guy there. Okay, now he misses the ball. Oops. Turns around and runs along path parallel to the baseball's path. So he's going to go parallel. Parallel is up 1 over 3. 1, 2, 3. Up 1 over 3. 1, 2, 3 if that continues. And he's going that way. Parallel to the ball's path. And what they're saying is, what is the equation of the line representing this player's path? Well, do I have a point? Well, of course we do. 90 and 40. Do I have a slope? Yes, we do. Right there. Oop, that's not my slope. Where's my 90 and 40? I'm moving stuff all over the place. We have a slope. It's 1/3. It's 1 up, 3 over. So I can now write for my 5 got it. We're going to bring that down. And again, well, I'm not going to write it. You're going to write it. Point slope form. Go for it. Okay, welcome back. We got y minus y1 equals m, x minus x1, and we got y minus 40 equals 1/3. Remember, that's my slope because that goes right in here. I got my 40 goes in there. My 90 is going to go in there, so x minus 90. Okay, and right now, they didn't ask me to do anything more than point slope form. But because it's a fraction, I'm going to have you go to slope-intercept form. Remember, this is point slope form. Okay, now slope-intercept form, solve for y. So solving for y minus 40, distribute to 1/3, 1/3 x. 1/3 of 90 is 30, or if I do 90 divided by 3, that's just going to be 30. And now I'm going to add 40 to that, so y equals 1/3 x plus 10. And this is slope-intercept form. I hope that goes well. If you have any questions, please ask one of your local geometry teachers for assistance. Okay, and as always, if you're having difficulty, you should get help and you should ask questions and you should get your assignments done and reread your notes. Part of your summary today, use the lesson's objectives in your notes to reflect on what we learned today. Our objective, keep in mind, to relate slope to parallel and perpendicular lines and look at the front cover of your notes. This is Chapter 3, Formal Scale. Check off the remainder of the things you have left and pay attention to the things you don't, because the things you haven't checked off, you need to seek out enlightenment because it is time to prepare for the test. We have a chapter test coming up in the next couple days, so make sure you're ready to rock and roll. Today's assignment is 12 to 20. Okay? That's problem 12 to 20. And again, when you have a situation like problem 20, you have to find the slope. Now, what's really cool about 20, that slope, because it's in point slope form, but this one isn't quite yet. Y is equal to 2/5 if I divide by 5, x plus 6/5. So this is slope, and this is slope. Now you have to determine if those slopes have a product of -1 if it's going to be perpendicular. So -5/2 times 2/5, and that looks like -10/10, which is -1, so lines are perpendicular. So that's how we do 20. You come up with what the answers would be for 18 and 19. Okay, hope things are going well. If you have questions, again, talk to your local geo teacher. Have a super day.